So today we're learning about measuring, right, and segment measures. And we measure our segments in this class in centimeters. So when you have a ruler from home or a ruler that we used in class, you want to make sure that you're using the centimeter side of the ruler. And then you want to make sure you're lining that ruler upright. So I can't show a ruler on here, but I'm just going to point out that you want to make sure that the zero of the ruler is lined up with the start of the segment. And then you're going to look at the end of the segment and what it's pointing to. And this one is about at 3.5 centimeters. So you'd always want to write the number to the nearest tenth and the centimeters. You don't have to be exactly the same as me. So if you measure this one, I got 4.8 centimeters. If you got 4.7, 4.8, 4.9, close to that range, you should be fine. If you measure this one, let's see what you get with this one. Start with the 0 and line it up. It's not very long there. Did you get 1.5 centimeters? That's what I got. And how about number 3? If you line up number 3 with the 0 at the beginning, I got 4.5 centimeters. So that's just a quick thing, right? And we want to make sure that we're in the ballpark together with what we have. But most of the time we won't use a ruler, right? We're going to use what's called the segment addition postulate. And the segment addition postulate says when you have like a point that's between two other points. So for example here, A is between C and T. A is between C and T. A is between C and T. And so that's going to mean that if we added up this segment here plus this segment here, that it's going to equal the big segment. Or I would say like CA plus AT equals CT. And that's called a segment addition postulate. So here we have it with A, B, and C. So here you see that B is between A and C. There's B, between A and C. And if we add up AB plus BC, we get the whole segment of AC. So we're going to draw little pictures here that O is between J and B. So here we have like J, and we could put the O anywhere. It doesn't have to be in the middle. But the segment addition postulate says if you add the two little segments together, you get the big segment. Or E is between K and Y. So like here's K, here's Y, and E is anywhere in between. So if I added up KE plus EY, that would give me KY. We're mostly going to use numbers though, and this is going to be very intuitive. So I see that KL is 24 and LM is 12, and it's asking me for KM. So it's asking me for the whole segment. So I'm either going to add those numbers or subtract them. What do you think I would do? You're right, you would add them up. 24 plus 12 gives the whole segment is 36. Here, 5 plus we don't know what adds up to 15. So we're just going to subtract, right? 15 minus 5 is 10. And you don't have to show that work, you just intuitively can know that. In number 8, there's kind of a two-part question. So the first one is QS. So QS goes from Q to S. So do you agree that that one would be 31 plus 30 or 61? And then PQ is here. PQ kind of uses these numbers where it would be 55 minus 31 is 24. It's very intuitive, either adding or subtracting. Then we make it a little bit tougher with just like a little equation, really, right? So the equation here, we're going to add these two segments up to find GI. So 2x minus 3 plus x plus 4. Now, I said equation, but this is actually an expression one where there is no equal sign. We're just combining like terms, 3x plus 1. Same thing here, we're looking for this segment And so we're going to do a subtraction problem, 4x plus 4 minus the quantity 3x minus 4. That minus is going to have to be distributed, so minus 3x turns into a positive 4. So this is going to simplify to x plus 8. So it's using some of our algebra skills from last year. Finally, in number 11, now we have an equation, because now we're given all pieces of the puzzle. We're given the two little segments, and we're given the big segment. So now we're going to add up the two little segments, 3x plus x plus 8, and it's going to equal 32. And you're going to see this in the homework where it will say in the directions if you're doing an expression like 9 or 10, or if you're going to do an equation like number 11. And this one here is 24, and divide both sides by 4, so x is 6. So you can see how we transition from letters to numbers to variables, really, and expressions and equations. Last thing we're going to introduce is a really important word, congruent. Congruent all year long is going to mean the same. We're going to start off with segments, and congruent segments have the same length. And this is our symbol right here we use for congruent, the equal sign with the squiggle. We're going to mark on our picture. Here it says that AB is congruent, there's that symbol, to EF. If we want to mark that AB is congruent to EF, we're going to do these little tick marks. You can see I did like 2 tick marks in AB and then a corresponding 2 tick marks in EF. That shows that those segments are equal to each other. I don't always have to use 2 tick marks. If I want, I can just use 1 tick mark. Like for here, to show that those are congruent, I just did 1 tick mark through CD and a matching 1 tick mark through MN. We'll do more with that in the future, but now we're just kind of starting it. Here they're asking, are these two segments congruent? Is AB congruent to CD? Well, we got to count. AB goes from 1, 1 to 6, 1. So 1, 2, 3, 4. It's a length of 5. And CD goes 1, 2, 3, 4, 5. So are those congruent? Yes, they are. Right? They're both 5, so they're equal. Here, AB looks like it's only 1, 2, 3, where CD is 1, 2, 3, 4, 5. Are those congruent? They are not. They are not the same length. So what we talked about is segments in their measuring with centimeters, lining it up right with a ruler. Segment addition postulate, that the two little segments add up to the big segment, doing that with letters, then numbers, then expressions. And then the idea that congruent means the exact same length.